This video is all about Git and GitHub. When I started programming, I didn't understand if they were the same or different things. Turns out that Git is software used for organizing your work, and GitHub is a service that allows you to save your work online. However, GitHub would be nothing without Git, the software that drives all of this. I'm going to be explaining this through the eyes of a friend. This friend's name is Katie, and she is an octocat. Katie is a hard-working octocat, and she takes her work with her wherever she goes. She works on her desktop at the office, she has a laptop that she brings with her when she travels, and she works at a computer at her home. To bring her work with her everywhere, Katie uses a thumb drive, but this has proven problematic in many ways, especially when she forgets to bring it with her. So Katie's decided to design an online solution for storing all of her work. What should Katie's solution be like? Well, it certainly can't be like a thumb drive because it can't be a piece of hardware that can be lost or forgotten. It can't be saved on Google Drive because as a programmer, Katie's files need to run on certain programs and not a word processor or any apps on the Google suite. It can't be something like Dropbox because Katie's files are huge and in a single sitting she can edit dozens of files, which would take forever to upload or download. Now that gives Katie pause to think, because when she thinks about how much work she does and how many files she edits, she realizes it would actually save a lot of time if instead of saving the individual files, she could save just the changes to those files. Not saving the whole file, but saving changes. What would that look like? Well, Katie knows that she does most of her work in 3 locations: home, work, and school. Now, initially, all of those locations would have the same project, all synchronized. We'd call that version 1.0, and we would have a version of that stored on the cloud as well. When Katie was working at home, she would make a change and save it, and upload just that change to the cloud. Then, when she went to work, she would download just the changed part of her file to her project at work. And that way, both her home and her work would be synchronized at the same time, but the only transaction would be just the change. We might call that changed version 1.1. So, at work, she makes another change, and then she uploads that change to the cloud. Katie goes from work to class, and she needs to download her work from this morning and from work. She downloads the new version by only taking the 2 most recent changes. This system is Git. So all we have to do is assign some vocabulary to it. Those locations, home, work, and school, each of those is called a repository. And since those repositories are on machines that Katie is sitting physically in front of, they're called local repositories. The location on the cloud is something that Katie will never be able to touch. It's a remote repository. These changes that she's making, saving and uploading and downloading, are called commits. And when she sends a change from a local repository to a remote repository, we call that pushing, while taking it down from the remote repository is called pulling. So far in this example, we've been talking about Katie working alone and managing her own work. How would she do things differently, however, if she had to work with other octocats? In this example, Katie and Jim are co-workers working on the same project. So Katie has a repository and Jim has his own repository. Now in Jim's file, he makes 2 changes, 1 edit and 1 deletion. When he's all done, he commits that, meaning he seals it as having been completed, and then he pushes it to the remote repository. In Katie's file, she makes a change to a different part of the project and she commits that, pushing it to the remote repository. What's going to happen? Well, Katie's attempt to push is going to fail. She's going to get an error that says rejected, non-fast forward. What do you think that means? If you take a second and think about it, you might be able to guess. See, the remote repository knows that Jim has made a commit and it's no longer synced with what Katie has. In order for Katie to push her commit, she's going to need to pull Jim's commit first so that her files are up to date. Then she'll be able to push her commit. So Katie does this, and it goes smoothly because Jim has made edits and deletions in different parts of the project. That was simple. Let's try another scenario. In this scenario, Jim, again, makes 1 change and 1 deletion. Katie, on the other hand, doesn't do a deletion. She makes a change where Jim deleted. Once again, Jim pushes first. Katie attempts to push, but it fails because she needs to pull Jim's commit, and we have a new type of error. This type of error is called a merge conflict. because when Katie attempts to pull, the files don't match up. And so we have two versions. Now, the version that Katie's currently looking at, the one on her local repository, that's called the head. And then the one that's on the remote repository is just called the remote branch. We haven't talked about branches yet, but we will soon. Anyway, Katie's going to be asked to compare and to resolve the two conflicting commits. How this is done in real life can vary depending on how the team works, but in this example, we'll say that Katie decides that her edit is more important than Jim's deletion, and she resolves the merge conflict by committing her version. There is a way that Katie can prevent getting this rejected non-fast forward error. She can actually verify whether or not changes have been made to the remote repository by fetching the remote repository. When you fetch, you look to see if changes have been committed to the repository, and then if they are committed, you can decide whether or not you want to pull them. Just a minute ago, I said the merge conflict asked Katie to compare the head and the remote branch. Let's talk about what a branch is. When I began my introduction to Git, I talked about how Katie had a repository at home, work, and school, and on the cloud. I said that initially they were all in sync with version 1.0. Since those are all synchronized to the same thing, and that same thing is version 1.0, we're going to call that master, like it's the master version of the whole project. So in this scenario, Katie's at school, and she makes a substantial change to the project, but by the time it gets to the end of the day, she's not quite finished or satisfied with it, and she needs to save her work, but she's not sure if she wants to override the master version of the software. I mean, what if she continues down this path and it ends up not working out and she wants to revert to the original? Like, she wants to commit it, but not like fully commit it. So we're gonna do something differently this time. We're gonna go ahead and we're gonna save it, but as like an alternative version of the project. Instead of master, we'll call it beta. So these two versions, this master version and the beta version, we're no longer going to use that word version anymore. We're going to call them branches. Branches give us a way to work with our program without having to change the master version. Any pulls that she attempts will be pulled from the master branch. And if she wants to switch over to the beta branch, she can. All she has to do is check out the beta branch. Checking out a branch, that's also Git terminology. And by the way, we're not going to drop the word version from our vocabulary. Whenever we do make a change to the master version or the master branch, we'll just increase the version number. Making changes to the version number of your branch is called tagging. So this is the framework for a big idea called version management. Git is an incredible tool for helping programmers both working in isolation or on teams to manage what could otherwise be an unwieldy amount of changes and versions. And of course, we wouldn't be able to use it the way that we do if we didn't have a remote repository to save it all on. GitHub is that resource. I hope this video answered some questions for you. If you liked it, don't forget to give it a thumbs up, and I would encourage you to subscribe because I weekly release videos about innovation and education, and I'm currently doing a whole series on web development, starting with the very basics and working all the way up to a modern app using Angular and Google Firebase. Keep asking questions, keep learning new things, and if you do that, you can bet I'll see you there.